Hello, in this video we are going to continue working with the ball shooter simulator, and we're going to set up our project and be introduced to the state machine templates that I've developed to help students and programmers develop state machines in their FRC robotics robot programs. So if you are unfamiliar with LabVIEW, or you haven't watched the state machine videos, I would recommend that you go to the PorterBots website on YouTube and watch those videos so that you can be caught up with where we're at. So if we just go to Google and type in PorterBots. PorterBots YouTube channel and PorterBots YouTube. You will see that the Lockport PorterBots have posted several of my videos. So if you're new, and I have a lecture series here of 4 separate videos that I presented to PorterBots back in 2016. And then I've also, there should be a ball shooter simulator open and start, where I give a demo of using the ball shooter simulator, and then this video is a continuation from this ball shooter open and start video. Okay, so the first thing we're going to do is we're going to go to the location where I've saved the first demo, the demo 0, and you can find that by going to this link, bit.ly link. So if we open a new web page, we type https://bit.ly/capital G, lowercase g, lowercase l, 83m. This will take you to my Google Drive location, where I'm storing all of my demos and utilities. So there may be several more here by the time you get here, but we're going to download the templates and utilities zip file and the demo 0 ball shooter zip file. So I'm going to right click, download, and I'm going to put these on my desktop. Right click, download, again on my desktop, and then I'm going to hide the browser here, and you should have these 2 zip files, and let's extract those. So I'm going to right click, go to my zip, and just say extract here right on my desktop. Do that for both of them. And then I can get rid of these zip files. Okay. And so I want to keep my demo 0 as is in case I need to go back to it. So I'm going to copy this, Control C for copy, and then Control V to paste it. And then I'm going to take my copy and just rename it so that I don't get it confused. I'm going to call this demo 1 and get rid of this copy code text. And then I'm going to take my templates and utilities folder, and I'm going to place it inside my demo 1. So we're going to move this into our project. And we're going to open demo 1, and we're going to place the templates and utilities inside the RoboRio folder. Later we're going to add a dashboard folder, and we're going to add a share folder where both the RoboRio code and the dashboard code will use the shared folder. The VIs inside the shared folder. So I'm going to open RoboRio, Here's where my project is, and we're going to open the Demo 0 project, and we're going to rename that to Demo 1. So double click on the Demo 0 project and then let it open up. Okay, now that I have my project open, I'm going to rename this project to Demo 1. So I'm going to say File, Save As, Rename, Continue. And I'm just going to change this 0 to a 1. And then click OK. Let it save. And now you see I have a Demo 1 project. Okay, so I'm going to show you how to change it from this virtual folders, using virtual folders, which are these gray folders, to an auto-populating. And I think auto-populating is a little bit easier for newer users to use, as it continuously maps what Windows shows in the folder. So let's delete all the items inside of this project. So I'm going to select, I'm going to hold down the Shift key and select all items, and then I'm going to press the delete key. It's going to tell me everything's going to be deleted. And you should just see my computer with dependencies and build spec and RoboRio target with dependencies. Okay, so we're going to add that RoboRio folder into our project. So we're going to go up to my computer. Now because this is the simulator, we're going to do everything in my computer. But when you actually use a RoboRio, you'll need to add code to the RoboRio if you want it to run on the RoboRio. So for the simulator, everything runs in my computer. So I'm going to right click and I'm going to say add folder auto populating. And then I'm going to open the RoboRio folder from my Demo 1 ball shooter. See these two folders, and we're going to say select this folder. So you're telling LabVIEW I want you to auto-populate everything inside that RoboRio folder. Okay, LabVIEW's completed auto-populating our RoboRio folder. So if we look, we'll see that it mapped everything that is in our RoboRio folder. So if our RoboRio folder is here, it should be a one-to-one match from what our project sees to what is in that folder. Brings in every file we want, these alias files and everything. Okay, now we're going to save this. So it saves our auto-populating settings. Okay, so a couple things. This is my RoboRio folder in Windows, and I'm going to close this. But say I want to open my RoboRio folder in Windows, I can click on my RoboRio auto-populated folder here, and I can right-click, and I can say Explore. Click on Explore. It'll open that window, or it'll open all those files in Windows. See, this is my RoboRio folder. Okay, so now we have our project. We have a systems folder. We have our templates and utilities. These are the templates, state machine templates I'm going to show you how to use. And we have a few utilities. One is a global stop that will stop all of our loops. And this is a little detector that for button changes. I'm going to show you how that used hopefully by the end of this video. Okay, so got our project set up. It's auto-populating. Now the first thing we want to build is our game controller VIs that will constantly monitor our game controller. So I'm going to open up the driver station, make sure that my game controller is plugged in. Okay, and I have my game controllers plugged in, and we go here to the USB tab, and as I move axes around, you'll see axes and buttons and POVs all responding. Okay. Alright, so let's go to our project. I'm going to hide the Windows view of this. Let's go to our project. So we're going to create a new sensor template. So the game controller is actually a sensor. It's a human sensor. It senses human actions. So we are going to create a new sensor template. So we're going to go here to our system templates, our template sensor, and this is called a library. So in the library are all these items that will help us create a sensor based state machine. And so we're going to copy these and we're going to put this in our system folder. I'm going to call it game controller. So I'm going to right click. I'm going to say save as. I'm going to create a copy and I'm going to call this game control sensor library. And I'm going to say add to the project and click continue. And then I'm going to go to my RoboReal, go down to my systems folder, and I'm going to create a new folder and to put my library in, call it game controller. And then I'm going to put that in the current folder. And so we can close this up. Now if we look in our systems folder, the auto-populating folder, created a game, we have a game controlling folder, and there's our game controlling library. Okay, so if we just do a brief overview of the main VI inside of our library is the sensor loop. So if we just open up our sensor loop, you'll see our code. This is kind of our template code to help us. And then everywhere we see this pound add code, we want to put code in there that will represent the hardware that we're kind of interacting with. Okay, so we'll put this aside for right now. So we're going to go back to our project, and we are going to create an icon. So if we have a library, we can create an icon for the library, and then every item inside our library will have this template VI or this template icon that we create. So I'll show you what I mean. So we're going to click on the library, and we're going to right click, and we're going to go to properties. Okay, so you can see here that this is we're in the library properties, and we can actually edit the icon of the library properties. So we'll bring up the icon editor, and we get to pick, we can create a template so that all the items in our library will have this header in it. Okay, so I think my joystick VIs are yellow, so I'm going to select the color yellow, and I'm going to get rid of all this code inside. Delete, and then I'm going to get the fill tool, select yellow, fill it with yellow. Then I'm going to take the text tool and type in, I'm going to go to black, use black text, I'm going to say game. Then you can use the arrow keys to kind of move it around. CTR, CTL. Try to get it to fit in there. How about game CT? And I'm going to click OK. And then it gives me my thing, and then I'm going to click OK again, and it's going to tell me, hey, you've changed the color of your icon. Would you like to apply this header or this icon to all your other VIs? I will click yes, and then we will save. And now we'll see that my sensor loop here now has the library header, and as well as all my other VIs in that library. They all have this header. So that's the way to get all our VIs in the library, kind of have a consistent look to them. I'm going to go to my project and we're going to save all. It's always good to do that. Alright, and then we're going to start building our joystick VIs, or game controller VIs. Okay, so we're going to bring up the block diagram, hit Control E. And we're going to go through steps of our template here. So the first part is where we build all our data into a cluster. So this part is all the constants that represent each individual data that we're going to put in our cluster. And then the sensor that we are going to use, this is where we will open that sensor and we will create a sensor reference. And then we should be ready to then enter the loop. So we start in our loop, and the first section here is we will read our data that we need to run our state machine. So in this instance, we are reading the current time, and we're saving the previous time so we can do some calculations later. We're also setting the loop speed limit, so we limit it to this time target. So for in this instance, our time target is 50 milliseconds. So the maximum speed that this loop can run is 50 milliseconds due to this wait. And then our next section, we are doing calculations. So any calculations that you need to do every iteration, you would put kind of in this area. One of the things that I've added to all the templates is the ability to calculate the cycle time of every loop. So you can have this calculation and you can look to make sure your loop is timing or cycling as fast as you programmed it to. And the other thing we do in this section is we look for the stop button to the global stop to be true, and if so, we go into shutdown mode of this loop, and if it's not stopped, we just transmit the state, the previous state that we're setting up. The next section is our state monitor section. We look at each of the states depending on the state that comes in. We look at the logic, and then the logic determines what our next state is and what our list of actions will be. So this action list is an array, so you can stack up and have there be multiple actions to be done depending on what the state needs. The next section will be our action loop. So we will go through each of the actions that this array has in it. We will do each action one at a time. And then when we complete, the final thing we do is produce and broadcast out all our different outputs. So in this section up here, we're writing to terminals on the front panel. And this will allow us to quickly open that front panel if we're debugging and see what certain status data is. And then the other thing we will do is we will take and put our hardware in here, our read hardware for our sensor, and then we will take that sensor data and write it to global variables and put it back in our cluster. And then the final, once our loop is completed or something tells our loop to stop, we will put our hardware in here, BIs in here to close the reference back up. Okay, so let's start building this loop for a game controller. I'm going to open my WPI library, and I'm going to go to the joystick palette, and I'm going to start pulling off the items that I need to make this a game controller loop. So first thing I need to do here is we need to open a joystick. So I'm going to bring my joystick open. I'm going to create a constant and select USB 0. That's going to be my first item in my driver station. So if I bring my driver station back up here, you see that this sensor reference is going to refer to USB 0, which is the first item in my driver station. So this is 0, item 0. And if I plug in another game controller, that'll be probably 1. You can move these around. One thing to note is if you double click on the controller and it's not underlined, then it can be moved around automatically. But if you say, this is my game controller, if I double click in here, it will underline it. So every time I plug this controller in, it will go to 0, to the 0. So that will help your driver and your operator, will help them from getting their game controllers kind of reversed. Okay, so back to our sensor loop. So I'm going to remove all the placeholder stuff here now that we have our USB. And then the other thing I'm going to do is I'm going to show you how to add. So if I want to do 2 game controllers, I might as well have this loop monitor both of them. So I'm going to create a second game controller. So the first thing I need to do is I need to add it to my cluster. So I'm going to add an item here. I'm going to take and I'm going to hold down the control key and I'm going to drag so I get a copy. And I'm going to call this sensor reference 1. And I'm going to bundle it into my cluster. So now I have a sensor reference 0 and a sensor reference 1 data item in that cluster. And I'm going to go to my bundle by name and unbundle sensor reference 1. I'm going to change this to USB 1 and I'm going to bundle that in my second. So now I'm opening my 2 controllers, a USB 0 and a USB 1. So okay, we have our hardware set up and open. So we go to this section and we're going to read any external inputs. So with the game controller loop, there's not really going to be any external inputs. So we can actually remove this global variable. No teleop or autonomous or another command loop are going to give any commands to the game controller loop. It's just going to continuously run. So I'm going to delete this. We're just not going to use it, and I'm going to close this up. And then I'm going to do a file save all. And let's move on to the next section. The next section we are doing calculations. So we're going to do our time calculation and we're going to look for our stop, but at this point we're not going to do add any additional calculations. we'll go into our state here. So these are the default states that this template allows you to have or gives you, and you can add or delete whichever ones are appropriate. You typically want to keep the startup and the shutdown state so that you do something when it comes to startup, you at least initialize or set up. So our startup state, we're going to want to immediately go to the enable, and we are going to want to enable the read. Okay, you may want to send a reset. There's some kind of just some default actions, but again, you can choose or change or delete whichever ones you want. So I'm going to go to startup, and startup is going to call enable state, and it's going to say read enable. When we go to the enable state, we are just going to always stay enabled. So I'm going to remove this case structure. It's not needed. And we are going to continue to read enable. And get to disable. Again, we go back to enable. There's no disable stuff. And there's no reset. So we can either delete this case, but we also have to delete it from the enum. So we'll show you how to do that. So let's go find, this is our state enum. Okay, and we're going to go edit this. So I'm going to click on it, we're going to right click, and we're going to say open type definition. So this is our game controller enum state, and we're going to right click here, and we're going to edit items. And we're going to get rid of the disable state, and we are going to get rid of the reset state. And then we're going to click OK, and File, Apply Changes, and File, Save All. Okay. So now there's going to be some extra states here. Startup is still valid. Enable is still valid. You see this is kind of grayed out, saying, well, you used to have a disabled state, but now it's not here anymore. So when you see this kind of grayed out enum, we're going to want to right click on it, and we're going to want to review and update from typedef. And this will bring us up a dialog box, and it says, okay, previously there was this disabled state. I don't have that anymore. Do you want me to replace it with startup? If you do, you can say approve, and if you do not, you can say no, replace it with enable. Approve that. Disable, replace with enable. Reset, also replace with enable. So you see we went through everyone on our list, and then we can apply changes. Right. So that fixed one thing. And so if we go to the disable state, you see disable, since it no longer exists, it's now in red, and we can just right click and delete this case. Enable is now duplicated, so this was one enable, and this is another enable because we got rid of the reset. We're going to delete this one. And so then when we're all done, all cleaned up, and you see now we're back to having a nice white arrow, we should only have our startup state, which we immediately go to the enable state, and we send an action of read enable. In our enable state, we come back to the enable state, and we say read enable. In shutdown, we stay in the shutdown state. And we set an action of read disable. Okay. All right, so we got all our states set up. We may have to come back to this if we discover that we need to do some more programming, we need to add states or whatever, but just kind of a quick walkthrough. Now we'll go to our actions. So the actions that we have for this are we just going to enable and disable our read. So these resets, all these resets for resetting enable and disable, we're going to remove those because we don't need them. They don't do anything anyways. The two defaults, there's no action. You always want to have a no action. And then reset time. So if you're doing timing functions, this is an action that's already there, and all it does is take the current time and put it into start time so that you have a kind of a record of starting a time at which you started some kind of timing function. So I would leave this one because you typically come back and need to do timing functions a lot, so I wouldn't delete this one, but right now we're not going to use it. So we need to go to, and we're going to remove all our resets. So let's go find the enum for our action. So if you look over here to the left, I've created just kind of a holding place for our states enum and our action enum. So we're going to right click on our action enum and we're going to say open the typedef. And then we're going to go and edit the items. And we're going to remove our reset. So reset enable, we're going to delete, and reset disable, we're going to delete. So we're going to keep a read disable and a read enable, a reset time, and a no action. Click OK. And we need to apply those changes. And we need to disable. Right, and then we'll close it. I see again it's grayed out. So we need to right click and we need to review and update all the typedefs. Right, looks like we only have one in our list. Reset disable, we want to replace with read disable. And we're going to say approve that, change, and apply changes. Okay, so we go back to our action list and go through reset time, read enable. See, we have several read enables because we deleted. This is what we want. Read enable, we should set the read enable bit to true. So this other one needs to go with false or delete. So we're going to delete this case. Read disable. We already have a read disable that's at false. So we're going to delete this one. And our arrow went white, which means that now we have a case for every single action. And simply what we do for read enable is we set the read enable bit true, and the read disable, we set the read enable bit to false. So we've completed all our actions. And then we're going to move over here to writing our outputs. So here for the sensor we have the read enable. If it's true, we actually will read the sensor and produce data, and if it's false, we will not read the sensor and produce maybe default or zero data or whatever we deem necessary. Okay, so there's some default stuff that we may or may not use depending on the sensor. So we have this sensor input, and again, there's no inputs or sensor inputs for the game controller, so we can actually remove this from our block diagram. Alright, so we're going to bring in, so we have two joysticks, or two game controllers that we're going to need to bring in. So I'm going to delete this this code because it's just a placeholder code. that we need to add in. So we're going to bring our sensor reference 0 and our sensor reference 1. And when our read is enabled, we actually want to read our controllers. So I'm going to grab the get values and I'm going to click on it and do a control drag so that I have two. And first one wire here and the second one I'm going to wire here. Oh, so when I'm moving, you see me moving icons around, I'm actually pushing the arrow keys up and down, left and right. You can move them 1 pixel at a time. If you hold down the shift key and move up or down, it will move 8 pixels at a time. So it allows you to kind of fine tune the movement of each item. And so I need to put my two sensors 0, sensor reference 0 and sensor reference 1, and wire back into them. And I go to the false case. I need to wire 0 to 0 and 1 to 1. So we're just passing those through on the false case. Alright, if I hit Control H, I want to understand the different values that come out of my joystick get value. I'm going to hit Control H. You can see I get context help over here. And then as I hover over my get values, you see that this VI produces 3 arrays. An array of axes, an array of buttons, and an array of POVs. Okay? So that's the data. Those 3 arrays are the data that I want to transmit to the world, or to the outside other VIs or other loops, specifically teleop. So I want teleop. I want to put all these 3 arrays in my global, in the sensor global that I'm responsible for, and then I'm going to have teleop read these values. Okay, so let's go back to our library and open our global variable that this loop is responsible for writing to. So any block diagram or front panel, we can get back to the project really easy by hitting Control Shift E. And will jump us right to the project and highlight the VI that we were in. So here's our sensor loop. So we're looking for the global sensor data out, okay, which is this loop right here. And we're going to open that front panel of that global. All right. Now in here we want to put 3 arrays for controller 0 and 3 arrays for controller 1. So one way to do that is we can just create constants and copy those and paste them over here. That's usually what I like to do. So I'm going to create a constant for the axes. Just drag them down here temporarily, and then I'm going to create a constant for the booleans, and I'm going to create a constant for the POVs. And then I'm going to show their labels, so I'm going to right click and say visible items label, and POV label. Okay, and I'm going to take these and put them in 2 spots. One, I'm going to bundle them into my master cluster. So I need to go back to the left there and add those items. And I'm going to put them in the global variables as well. So I'm going to highlight these 3 and I'm going to copy, Control C, copy. All right, and let's drag them over here. this out of my way. All right, and I'm going to call this axis 0, buttons 0, and POVs 0. And then I'm going to move some more room here, and I'm going to paste another set and call these axis 1, buttons 1, POVs 1. Alright, I'm going to add 6 items to my cluster. 1, 2, 3, 4, 5, 6. I went too many. And then I'm going to clean this up a little bit. So I'm going to select all these items. And then I'm going to vertical compress and maybe align left, maybe align right. And then I'm going to save all. Alright, so I created 6 arrays, and now I need to, we're going to go back, and I'm going to add items here in my unbundle array and put those 6 arrays that I just created into my cluster. So I'm going to come here to separate. I'm going to add an item in between. So I'm going to just say right click and say add element. And I'll make that axis 0. I'm going to add another element. I'm going to make that button 0. And I'm going to add another element. Make that POV 0. And I'm going to double click here and delete wires. Okay, so here's my axes for 0. I'm going to put that in. Here are my buttons. And here's my POVs. I'm going to clean this wire up so it goes to the right spot. Alright, so here we're going to put in axis 1, and if you pull down, I'll keep going to the next one. Button 1, POV 1. So we're going to go to axis 1, button 1, POV 1. Okay, so if my read is enabled, we go to the true case and we read sensor, or we read our joystick, our game controller 0 and game controller 1. And we take those values and we put them into our cluster. So the other thing we need to do is we want to write them to our global variables, because other loops like teleop are going to want to use them. Right? So one thing, let's go to our false case and decide, well, what do we do if I'm disabled? What values do I output? And you can kind of decide this out, but one thing we can do is we can say, I'll just use the default. And the default would be blank array, so you might as well send blank arrays. So what we're going to do is we're going to right click on each of these tunnels and we're going to say use default if unwired. Right? So if I don't wire anything to them, we're just going to use the default. Alright. Most of the time we'll be in the true case, but during shutdown or whatever, we'll just clear the arrays. Okay, so now let's add these 6 arrays into our global variable. Alright. So this is our global variable, but I'm going to show you how do we bring a global variable, the global variable that we want, onto our block diagram. So again, we're going to go back to our project. Remember, Control Shift E, and we're going to grab our global sensor data out global. I'm going to drag that right on the block diagram. All right. So let's open this up. So we're going to right click and say Open Front Panel. All right. And then we're going to put our arrays in here. So remember, I have those copied. I think if I just paste them, it'll give me three arrays: axis, button, and POV. And I'm going to just label them. So we need to follow this naming convention here. That's what this big yellow banner says. So this one I'm going to have to I'm calling it sensor, S-E-N, the library name right here, game controller, game, and then the data name. So this will be AXE, axis 0. All right. I'm going to copy this. I'm actually just going to copy this part so I don't have to retype it. This will be buttons 0. And this will be POV 0. All right, and then I can copy, Control C, copy, and then paste them, Control V. And I have access. I don't have to change those numbers because Levy does that for me automatically, luckily. So we have axis 1, buttons 1, and POV 1. Right, so there's my 6 arrays. And then these other two I'm not going to use, but I still want to do my cycle time and put that in the global. So we're going to keep this one. We just need to put in the naming convention. Oops. Sensor controller game controller cycle time. So we'll keep that VI, but these other two we don't need. Delete. Alright. So now I have 7 items in my global variable that the game controller will write to. So let's clean these up a little bit. I'm going to use stack to help clean them up. Okay. And we'll save. Alright, so I'm going to write to 6 global variables. So I'm going to start. So there's axis 0. And I'm going to hold down my control key and copy this 6 times. And I'm going to do an alignment here. And so, and then button 0, POV 0, axis 1, button 1, POV 1. Alright, so there's all the global variables I'm writing, and like so. Alright, and then this one we need to select our cycle time, and we're good. So then one of the final things we need to do is we need to, once our loop has stopped, we need to close our reference to our hardware. So we're going to bring the close in here for 0 and for reference 1. We're going to close both of them. And save file, save all. Okay, so let's do a quick review. Go through our program just to review all the things that we've done. And then we will try and put this loop into our robot main, and then run our robot main and play with our controllers and make sure that the controllers are working as expected. And then the next video we'll set up teleop to read these values. So first thing we do is we build a cluster of all the values that this VI looks at and writes to. One thing to notice is that you see these little red dots? They mean the coercion dots. So that means that the data that I defined here to put in the cluster is not the doesn't exactly match this data coming off the joystick open. So I'd like to fix that. So I'm going to just go to this wire, because I know this wire is the right data type, and I'm going to create a constant. And you see it creates a cluster with a USB enum in it, and that's not what I have here. And I'm going to name it the same thing. So I'm going to go visible items, label. I'm going to copy this, Control C, copy this value, paste it, and then I'm going to delete this and wire this one instead. And I'm going to copy this one and make it 0. And delete this one. And wire that in. So now I got rid of my coercion dots. Alright, so we bundled all our data in. We just read our times is all we're going to read for this. Just do our cycle calculations, look at our stop button, have 3 states that we got to worry about. All of them try to read or try to enable, and we do the action of read enable. There's our action, read enable. We set our read enable bit to true. And then you see we broke these. We got to reselect these values because we renamed them slightly. And then we have our right arrow. And then at the end we read our controller values, put all our axis array, button arrays, and POV arrays in their correct locations, and put them in our global variables so that we can read them later. And now we're going to file and save all. Okay, so let's go back to our project. Remember, we hit Control Shift E, jump us to our project. And we're going to open the robot main. And we're going to put all of our subsystems that we build from now on. It's our game controller subsystem. We're going to put that in time task. So I opened up time task. And here's time task from previous project. All right, so we're now that this joystick stuff is its own loop, so we're going to eliminate the joystick code out of here. So before I do that, we'll see that we're reading the button array off of joystick 0, and then we are pulling off button number 1, which in my case is the red B button on my controller. And then we are taking that value and determining how to set the scoops, the left and right intake motors. Okay. So temporarily, we are going to replace my global variable, my button global variables here, so that I can get rid of the joystick VIs. And I'm going to place the controller loop. So let's go find the controller loop. Here's the sensor loop for my game controller. I'm just going to place it here. And I'm going to get the sensor data out global. I'm going to drag it on this block diagram. I'm going to select the button 0 array. I change this to a read. Right click and change it to a read. So then I can delete all this data, because now my game controller loop is generating the button data. Like so. And I'm going to remove this as well. And we're going to save. Okay. So we also need to remove all the other joystick code that exists in there. So we go to begin. Begin also is going to have some joystick code that we need to remove. So I'm opening begin, and I find the joystick code in begin somewhere to the left here. Here's the joystick code. I'm going to delete that. And possibly finish, I think, or teleop will probably have some joystick code in it I need to eliminate. So let's go to teleop, Control E. Here's joystick code that is reading the access array for joystick 0 and the button array for joystick 0. So let's go find my global variables for that. Control Shift E, going to the project. My game controller global sensor data out. I want to change to read, and I want to read access 0. And I'm going to drag copy button 0. And I'm going to remove this code, replace it with access and button arrays. Save all. And the final location will be the finish, which will have the close in that. So I'm going to open the finish VI and look and see if I have any joystick code that closes. I'm going to delete this because I'm closing it with my other loop as well. Alright, so now I've replaced the previous code in the default from the default project with my controller loop, which I've put down here in time tasks. I have a sensor game controller loop, and it produces all the arrays, and those arrays are red here and they're red here at teleop, so that we can continue using the old stuff for testing. Okay, so let's make sure I have a driver station, and let's open robot main, make sure my game controller is plugged in, and we'll run robot main. Oh, there's still another joystick Yeah, I forgot to remove, so find that, delete it. Save, and see if we can close this. And let's try again. Open robot main, run robot main. Okay, so let's look and see if let's go here to back to time tasks and open our game controller loop. And we see that our cycle time are running about 50 milliseconds. There's still probably some stuff we could clean up that we're not using. So let's open our global variables, right click, or just double click. And we can see that we're reading, there's our array of axes for 0. And if I move some axes, you'll see that that data is getting saved. So going left, right on the left joystick, plus and minus. And then I go to index 1, going up and down. And my 0 button is my green button. See, that's getting pressed, and my red button here. And because I don't have a game controller plugged into slot 1, you'll see that I'm producing no arrays when I do that read. All right. So the next video we will do a little more with teleop. We will take the game controller globals and try to manipulate some stuff in teleop.